In the field of printed circuit board design engineering, crosstalk is the most common issues which are observed in the high-speed design engineering. In this video, let's talk about what is crosstalk and what are the types of crosstalk in a nutshell. Let's get started. Crosstalk is an electromagnetic interference between two parallel traces in PCB design engineering. If you are designing two parallel traces on the printed circuit board, because of electromagnetic flux or electromagnetic interference, the neighboring trace will get a noise induction. That particular problem is called a crosstalk. It happens most widely in the form of differential pair traces, especially which are not handled properly. For example, if you are connecting a I2C protocol based sensor to a microcontroller and you are drawing traces for SDA and SCL in parallel to each other with the proper IPC standards, but you have not taken care how to handle the EMI effect or EMC effect, which creates the problem with respect to signal integrity. That's when the crosstalk kicks in because of inducing a noise in neighboring traces for whatsoever reason. These type of problems are very common with respect to high-speed design, and how to solve them is a key challenge. Let's talk about the capacitive crosstalk. Capacitive crosstalk happens because of voltage difference between two parallel traces, which creates the virtual capacitance. And this capacitance will induce a noise in neighboring traces even though there is no physical connection between them. That's when the capacitive crosstalk comes into the picture, and it will affect the signal integrity of those two parallel traces. Second one is inductive crosstalk. Inductive crosstalk happens with respect to high current traces, which will create an induction of magnetic flux in the neighboring traces without having a physical connection. It's pretty much like a transformer behavior. When we have a primary coil and a secondary coil which are not connected physically, but they will induce the magnetic flux and transfer the voltage from one coil to another coil. Similarly, in these traces, if they are not handled and designed properly, they will create an electromagnetic interference due to the electromagnetic flux on the neighboring traces because of high current. This is called inductive crosstalk. In most of the high-speed designs, crosstalk is the most common problem which engineers faces while designing the PCBs. So that's why you must make sure that you adopt certain methodologies and IPC standards to solve or address the methods or the problems with respect to crosstalk. If not handled properly, signal integrity, EMI and EMC are the most common issues which will kick in while we are going for the certification. I believe you have learned something new from this particular video. Share it with your colleagues who want to learn about high-speed designs and PCB designing with respect to crosstalk and other technologies. Thank you so much for watching this video. Consider subscribing to our linked frequency channel for the more detailed videos on how to solve crosstalk issues on the PCB designing. See you again in the next video. Until then, tune yourself to make a difference.